So this is the Unit 6A handout for geometry. And it's basically just talking about fractions more than anything else, or really ratios. Um, so ratios can be written a couple different ways. Um, and ratio is basically, most of the time, the synonym for fraction. And the idea is that like if I said I've got a ratio, there are 8 boys in class to every 12 girls in class, you can write it as 8 colon 12, where you would say 2 for the colon. So it's 8 to 12. You could also write it as 8 over 12. That's an equivalent way of saying 8 to 12. And then you can simplify it. So like if I say there are 8 boys to every 12 girls, that's the same thing as saying there are 2 boys for every 3 girls. You just simplify the fraction. Or you simplify this colon notation and you write it like that instead. So these are all examples of ratios, right? Now a proportion is a little bit different. A proportion is when 2 ratios are equal. So this whole equation right there is a proportion. This whole equation is a proportion. A lot of times you use proportions to solve stuff. So like, let's say you do 4 over 5, one ratio here equals this ratio over there, right? And when you have something like that, where 2 ratios are equal, you call it a proportion. You can solve those. Most people usually solve it by using cross multiplication. And we'll eventually do that anyway. Okay, so let's take a look at number 1. Number 1 says express the ratio of 2x to 8y and simplify if you can. Well, 2x to 8y, I could write it as a fraction. So 2x to 8y. And then that one can be simplified. So 2 over 8 turns into 1 over 4. So it's 1x on top over 4y on the bottom. Or you could write it as 2x colon 8y and then simplify that to 1x to 4y. So there's one way right now, or here's the other way right now. Okay, sometimes you want to compare more than 2 things at a time. Like, let's say that I had 3 students and their test scores were like somebody got an 80, somebody got a 90, and someone got 100 on a test. Right? So I could say the ratio of their scores are 80 to 90 to 100, or you could say 8 to 9 to 10, right? That's the same ratio. When you have more than 2 terms in there, you never write it as a fraction. Like I wouldn't write this as 8 over 9 over 10. Like I don't know if that's 8/9 all divided by 10 or 8 divided by 9/10. So that nobody writes 3 terms in a ratio like this. Instead, they use this thing called an extended ratio, and you use the colon notation instead. Okay? So anyway, that's kind of the gist of what's going on in the paragraph up here. Down here, it says you've got 3 angles, that should say of, a triangle, are in the ratio 2 to 2 to 5. So find the angles. Okay, well, 2 to 2 to 5 are my 3 angles. That's not the same as saying, well, it's 2 degrees, 2 degrees, and 5 degrees, because if I added those up, I only get 9 degrees total, which doesn't make any sense for a triangle. I could double everything, but then that only adds up to 18 degrees, or no, not even that, 14 degrees. So that's still not enough. Oh, I didn't double the 5. It adds up to 18 degrees. I need 180 degrees. I could multiply this all by 10 and get 20 to 20 to 50. That's still not enough, though. That still doesn't add up to 180. So what I need is, I need a ratio, or an equivalent ratio, where the sum is 180 degrees. So 2 to 2 to 5 is the same thing as 2x to 2x to 5x. Right? This is the same ratio right here. These guys are equal to each other. So let's make x the kind of the scaling that we need so that those 3 angles add up to 180, and then we can solve for x. So this ends up being 9x equals 180. If I divide by 9, I get 20. So if I multiply the 2, and the 5 each by 20, I'll get the three angles that add up to 180. So one of the angles, so the three angles are 2x, which is 2 times 20, so 40 degrees. Another 2x, which is another 40 degrees. And a 5x, which is 5 times 20, so 100 degrees. And if you think about it, well, these add up to 180. So here are my three angles. Okay, number 3, simplify the following ratios. Okay, so simplifying fractions, you're looking for common factors that you can divide out of the top and the bottom. So like maybe you notice that 27 and 45, you might notice that 3 goes into both of those. So if I take a 3 out of the top, I got a 9. If I take a 3 out of the bottom, I'm left with 15. And then I could take another 3 out of the top and bottom. So 9 divided by 3, I'll get 3. 15 divided by 3, I'll get 5. So 3/5 is that ratio. In the next one, let me zoom in a little bit on this. Okay. So in this one, notice there's an A term here and an A term there. I can just cancel those guys out right away. And then 4 over 30, 2 goes into both of those, so I got 2 over 15. And then there's still a b on the top. So I'm just going to tack that on the top right next to the 2. So 2b over 15. Okay, the next one, let's see, we got the 6 and the 12. That's going to turn into 1 over 2. I have a b and a b on top and bottom, so those cancel. Then I've got a cubed over a. So let me write a cubed over a, and then I'll keep the c on the bottom so I don't forget it. So then the question is, what happens with the a's, right? You might know if you got 3 a's on top, 1 a on the bottom, you can cancel out one of them, you get 2 a's on top. But if you're a little rusty with those rules, you could write the a cubed as just a times a times a. And on the bottom we got 2ac, and then I can cancel out 1a with 1a. And then I'm left with a squared on top and 2c on the bottom. And then the last one here, part D, says, let's see, 2 parentheses a minus b over 3a minus 3b. Now, I'll tell you now, you don't have to write this part down yet. What a lot of students want to do is distribute 2a minus 2b over 3a minus 3b. And then the most common mistake I get is students say, so let's cancel the a's and let's cancel the b's, and I'm left with 0 over 0. But that doesn't really make sense. You're not allowed to have 0 on the bottom here, right? That's not okay. So notice you can't cancel the a's and b's here, and the problem is because of that minus sign. We're not multiplying every term together on top. We're not multiplying every term together on the bottom. There are these pluses and minuses floating around there. Whereas up here in A, B, and C, all we're doing are multiplying things together, right? So you're allowed to cancel from numerator and denominator if everything's being multiplied. So this one, we can't because of that floating around negative sign right there, the minus sign right there. So instead, let's try something different. Let's keep the top the same. And then in the bottom, you can factor out a 3. And then you're left with a minus b in parentheses. So now what we've got, even though there are minus signs here, it's really 2 times the number, a minus b, over 3 times the same number, a minus b. So the a minus b's cancel. And if you don't like it written like that, you could say, well, just turn a minus b into x, and then the x's have to cancel. So the a minus b's have to cancel, and you're left with 2/3. Okay. Okay, number 4. Let's see. Tree breaks during a storm. It snaps into 2 parts. If the tree had originally been 7 meters and the ratio is 3 to 2. Okay, so let's see. Tree parts are in a ratio of 3 to 2. So that means one part, the long part, let's say, is 3 times some amount, and the short part is going to be 2 times the same amount, right? Because that's the same ratio. 3x to 2x is the same as 3 to 2. Now it's not just 3 and 2, because that only adds up to 5, and it's supposed to add up to 7. So the sum of 3x and 2x, the total, is 7 meters. So we can set up an equation based on this. 3x plus 2x equals 7. So that's 5x equals 7. X is 7 divided by 5. And then you can plug that back into the long part and the short part. So then the long part equals 3 times 7 over 5. And in my classes, some students were saying, okay, think of it as 3 over 1 times 7 over 5. And then you multiply straight across the top and get 21, straight across the bottom and get 5. And these were in meters. By the way, if you prefer decimals, let's see, that's 4.2 meters. To get the short part, you could do two things. You could either subtract what you just got from 7, or you could do 2 times x, because that's what we said it was over here. So it's 2 times 7 over 5. So you could write that as 2 over 1 times 7 over 5. So 14 over 5 in meters. Or you could think of that as 2.8 meters. Okay. So let's try the next page here. And the next page is ratios equaling ratios. So when two ratios equal each other, it's a proportion. So cross multiplication is going to be the most standard way that I think most of you learned how to solve these. So cross multiplication, it's got to have an equals in the middle. And you would say x times 5 equals 4 times 3. So x times 5 is 5x. 4 times 3 is 12. And then if I divide both sides by 5, 12/5. There we go. In B, it's a fraction equals a whole number. So what a lot of students, I think, like to do is treat it like a fraction, 3 over 1. And then when you cross multiply, you get 8 times 1. So 8 equals 3 times x plus 4. And when you do that, anything that's more than one term, you got to put in parentheses. So when you cross multiply, you don't forget to distribute that 3. So let's subtract 12 from both sides. And we get negative 4 equals 3x. And then we'll divide by 3. And there we go. Okay, C. Let's see. So we can cross multiply here. We got 5 times x plus 2. So these guys go together. And then these guys also go together. So it's 5 parentheses x plus 2 equals 4 parentheses x plus 3. And then we got to distribute. So we got 5x plus 10 equals 4x plus 12. And then if I subtract 4x from both sides, then I get x plus 10 equals 12, and then I can subtract 10 and get x equals 2. Okay, so let's cross multiply in D. So it's these two put together equals these two put together. So it's x minus 1 times x plus 2 equals x minus 2 times x plus 4. And then these guys, you're going to have to FOIL each side. So when I FOIL the first part, the left side, it's first terms is x squared, outer terms is plus 2x, inner terms is minus 1x, and the last two terms is minus 2. And then over here we'll do the same thing. So it's x squared, and then outer terms is plus 4x, inner terms is minus 2x, and last terms is minus 8. And then we simplify. Now, one nice thing is you might think you have to use quadratic formula, but there's an x squared on this side of the equation and x squared on that side. They cancel. And then you can simplify. 2x minus 1x is 1x minus 2 equals, and then 4x minus 2x is 2x minus 8. And then let's add 8 to both sides. So then we get x plus 8 equals 2x. And then if you subtract x from both sides, you get x equals, whoops, sorry, I messed up here. This is a 6. So x equals 6. Okay, and then let's take a look at E. So we got 2x over 5 equals 6 over x minus 1. If I cross multiply, it's 2x times x minus 1 equals, equals 6 times 5, which is just 30. So then I got 2x times x, which is 2x squared. And then 2x times negative 1, so minus 2x equals 30. And then you could bring over the 30 equals 0. And then you could divide everything by 2 if you wanted to simplify that a little bit. And this one, you're not going to be able to solve it by factoring. So you could say a equals 1, b equals negative 1, c equals negative 15, and then plug it into the quadratic formula. All over 2a. And here, we'll do it on the calculator. So I'm going to store these values. A is 1 store as a. B is negative 1, store as alpha b. And c is negative 15, store as alpha c. Sorry if you hear the that blower thing outside right now. Okay, so let's get the fraction symbol. So that's under F1. So green button, F1, numerator over denominator. And then I'll do negative b plus the square root of b squared minus 4ac all over 2a. And I'll hit enter. And there's one of my answers. So x is about 4.405. Or the other answer, so I'll just come back up here, select it, hit enter to paste it, and then come back over here and switch that plus to a minus. Negative 3.405. Okay, now I'm not going to bother checking these because I know we did the algebra part correctly. The reason I'm not going to bother, I mean, if this were a geometry problem where we were solving like for an angle or a side or something, I'd want to plug these guys back in and see if the angles are positive or negative or if they make sense for the diagram. In this problem, we're just solving an algebraic question. So as long as you did the work correct, the answer should be right. That is loud. Okay, sorry, there's a blower right outside the classroom where we're recording this. I paused it. I think it shouldn't be too loud for you guys. Okay. All right, let's take a look at 6. So if you already know that a over b equals c over d, then why does this fraction, this proportion over here, have to be true? So let me write it like this. If we already know this is true, then we'll assume a over b equals c over d. In fact, let me write it over here so we have a little more space. Let a over b equals c over d. That's a given, right? The goal is down here to end up with, therefore, a plus b over b has to equal c plus d over d. So what I actually think is easier to do is take the end and see if you can figure out how to get to the beginning. Work backwards, right? A line that could come right before this would be to cross multiply. A plus b times d equals c plus d times b. So if we cross multiply, it's a plus b times d equals c plus d times b, right? And then from this line, we could get the line before it. The only thing I could think of doing is distributing. A times d plus b times d. And then over here, distribute the b. So b times c plus b times d. And then if I said, what could you do with this line? Well, there's a BD on both sides. That turns into AD equals BC if we cancel those out. Then if you look at that line, well, you can get that line from the previous one just by cross multiplying, right? So if we started out with this, you can get AD equals BC by cross multiplying. Then to get to the next line, you just add BD to both sides. To get to the next line, you factor out a D and a B. And then to get to the next line, you do the opposite of cross multiplying. It's like cross dividing, I guess, in a way. All right. Okay, let's take a look at the last one. 7. ABC is similar to FDE. Now, you might remember from last semester, congruent, the symbol for it is equals with a squiggle. Similar is just the squiggle. Okay? So if I put that right there, that means they're similar to each other. Okay, and similar, we talked about briefly last year. It's really same size, but not necessarily the same shape. Or sorry, same shape, but not necessarily the same size, right? It says it right here. It's basically like if you shrunk or expanded something else and kept everything in proportion, right? Just like when we did congruent triangles, the order that the letters are in matter. So if I said, what side goes with AB in this triangle, in the smaller triangle? So AB is right here, right? If I mark this with red. So here's AB right there, right? Well, what a lot of students try to do is gauge just by guessing how long, which side's the longest side. That's not the best way of doing this. The best way of doing it, if I give you the letters, is to say, well, AB is the first two letters, so that's got to go with FD. These first two letters right here, right? FD. The first two letters the way I labeled the triangles. So I know those two red sides go together. They kind of are corresponding sides to each other, right? BC is the last two letters here. So BC right here has to go with whatever are the last two letters over here. DE. Whoops. DE right there. So this one goes with this one. Which also means that the third sides have to match up. So that's going to be EF, right? This guy has to go with AC. Now you might be able to do it just by staring at them and saying which side's the shortest looking, but that's not going to be a reliable way if the sides are pretty close to each other. Right? So let's label what we know. AC is 7. BC is 9. AB is 13. DE is 6, and EF is the one we're looking for. So let's call that X. Now, the sides that go together, the corresponding sides of similar shapes, they're always proportional to each other. So we can set up ratios. And if you look at it, the green sides, 6 and 9, they both have numbers associated with them. So the 6 and the 9 are kind of the key to the problem. So I'm going to say the 6 up here from that small triangle goes with the 9 in the bigger triangle. The same way that the short blue side, X, has to go with the longer blue side, 7. Right? You could also set it up the short red over the long red too, but I don't care about the reds. Right? The real key to the problem is finding the two sides that go together that both have numbers associated with them. Because if you have those lengths, you can solve anything else where you know some of the info. Right? So if we cross multiply, let's see, we get 42 equals 9x, and then we can divide by 9. And then, let's see, 3 goes into both of those. So let's see, if I divide by 3, I get 14 on top over 3 on the bottom. So 14 thirds is EF. So EF equals 14 over 3. By the way, in a couple of my classes, we did this one. Instead of cross-multiplying right away, we actually turned the 6 over 9 into 2 over 3, and then that made the work a little bit easier later on. So 14 equals 3x, and then 14 over 3 equals x. So you could do it that way too, instead. So either one of these is okay. Okay, I hope that helps a little bit, and I will see you guys soon.